All right, when you're solving word problems using systems of equations, you're going to have to define two variables. And how do you know how to define the variable? Well, you've got to ask yourself this question. What's the problem asking me to find? In number one, it says the sum of two numbers is 64. The difference of the same two numbers is 42. What's it asking you to find? It says find the two numbers. Now, when you define your variables, you don't have to be any more specific than the question is asking about. So if you're finding two numbers, well, let x equal one number and y be the other number. And you've just defined your two numbers. Then you have to set up a system of equations. To do that, realize that each sentence will give you an equation. For example, here, the sum of two numbers is 64. That sentence is going to give you an equation. The sum meaning to add, obviously, so you add these two numbers up, x plus y equals 64. Then your other equation is going to come from the other sentence. Now it says that the difference of these same two numbers is 42, so that would be x minus y equals 42. And now you have this system set up so that you can use elimination. Add the two equations together, you get 2x. The y's are going to cancel, equals 106. Dividing both sides by 2, x is equal to 53. So one of your numbers, one number is 53. What's the other one? Well, the other number would be 11 because they add up to 64. Now, do you also subtract them and get 42? So yes, you've solved this problem. Number 2 is very similar to it. The sum of the two numbers is 18. The difference of the same two numbers is 22. Now, don't fret about what the numbers that you see coming up here. When you solve this system, you get x plus x is 2x. The y's are going to cancel. 18 and 22 are 40, so x is equal to 20. Put 20 back into either equation. It doesn't matter. I'm going to put it into the first equation. 20 plus y is equal to 18. Subtracting 20 from both sides. Well, you get y is equal to negative 2. No big deal. You get the point. 20, negative 2, or the two numbers are 20 and negative 2. Now, in number 3, Jim is older than Bob. Together, they're 60 years old. If Bob is 8 years younger than Jim, find the age of each. Well, again, we have to define our two variables. And again, ask yourself, what's it asking you to find? And it's asking you to find the age of each one. So we have to be a little bit more specific here as to how we define our variables. It's no longer just let x equal one number and y equal the other number. We're talking about Jim's age and Bob's age. So since we're talking about Jim, I'm going to say let J equal Jim's age. And then, of course, B would equal Bob's age. Now it says together they are 60 years old. That's one sentence. That's going to give you one equation. So J, Jim, plus B, Bob, is 60 years old. Now here's where things can get tricky if you allow it. I don't let things throw me off because all I'm going to do is I'm going to take the other sentence and literally translate it into another equation. Well, it says Bob is 8 years younger than Jim. Well, if you'll find the verb, you'll find the equal sign. So is the equal sign. Well, what is? Well, it says Bob is. Well, that's the word we have for Bob's age. What's the math stuff that we have for it? Well, we're using B for Bob's age. So B equals, Bob is, Bob equals, B equals. How do you take 8 years younger than Jim? Well, Jim is J, that's Jim's age. Younger than that, 8 years younger than that would be J minus 8. So here are your two equations. Now we're going to use substitution and put J minus B in, excuse me, J minus 8 in for B. So I'm going to have J plus J minus 8 is equal to 60. To J, I'm going to go ahead and add the 8 and get 68. J is equal to 34. Well, what does that mean? Well, J stands for Jim's age, right? So Jim is 34. Plug that 34 back into here. J minus 8, 34 minus 8 is 26. That must mean Bob is 26. Now make sure this thing works out. Is Jim older than Bob? Yes. By 8 years? Yes, he is. Do they add up to 60? It checks out. In number 4, I'm going to say that A is going to be Anita's age and B is Brandon's age. Anita is 4 years older than Brandon. So I'm going to take this sentence right here and I'm simply going to translate it into math. Here's the equal sign is. Anita is. What is? A is. A equals. How are we going to write 4 years older than Brandon? Brandon plus 4 years. A is equal to B plus 4. Then it says 3 times Anita's age, so that would be 3A, added to plus 6 times Brandon's age, 6B, is equals 48. So there's your other equation. We'll use substitution to solve this. We're going to take B plus 4 and put it in for A. So I have 3 times the quantity B plus 4 plus 6B is equal to 48. 3B plus 12 plus 6B equals 48. 9B plus 12 is equal to 48. 9B is equal to 36. That means B is equal to 4. So Brandon must be 4 years old. If that's the case and Anita is 4 years older, then Anita must be 8. Then it says the length of a rectangle is 1 centimeter more than twice the width. If the perimeter of the rectangle is 32, find the dimensions. It says find the dimensions. Well, that's what we're finding. So we assign L for the length of the rectangle and W for the width. Or you could just say let W equal the width and let L equal the length. Either way is fine. But if you draw a picture and label it, that would be good enough for defining the variable. Now we have to write 2 equations. The length of the rectangle is 1 centimeter more than twice the width. The length of the rectangle is, oh, there's your verb, there's your equal sign. So what's the length of the rectangle? We're now calling it L. So L equals, how would you write 1 centimeter more than twice the width? Well, it'd be 2W plus 1. And then we have to use, for our other equation, we're going to have to use the perimeter of a rectangle. What's the formula for perimeter? 2 times L plus 2 times W is equal to, in this case, 32. And we'll use substitution. So when you plug in 2W plus 1 in for L into the other equation, you get 2 times the quantity 2W plus 1 plus 2W is equal to 32. Using the distributive property, combine like terms, subtract 2 from both sides. Divide both sides by 6, you get the width is 5, because W stood for the width, right? How do you find the length? Right here. We're going to put 2 times 5 is 10 plus 1 is 11. And there are your dimensions for this rectangle. You try number 6 and see if you can come up with the same thing. Go ahead and pause the video and see if you can come up with number 6. Well, I've defined my variable. The L is used for the long side of the rectangle. W would be the width, the short side. The perimeter is 2L plus 2W is equal to 44.8. W is equal to L minus 3. Substitution. Distributive property, solving, you get L is equal to 12.7. L stands for the length, so the length is 12.7. The width, minus 3, 9.7. In number 7, geometry, 2 angles are supplementary if they add up to 180 degrees. The second angle is 16 less than 3 times the first angle. Find the measures of each angle. We're finding the measure of each angle. And how is it described in the story problem? It's described as the second angle and the first angle. So that's how I'm going to define my variables. I'm going to let x equal the first angle, and I'm going to let y equal the second angle. Now, Here's one sentence. They add up to 180 degrees. So x plus y equals 180. I don't think that one's so hard. Now, if you'll find the verb in the second sentence, you'll be able to write this equation. What's the verb? Is. So there's your equal sign. Well, the second angle is, so what is the second angle? And well, what are we calling the second angle? We're calling it y. So y is, the second angle is, you have y is. Now we need to take 16 less than 3 times the first angle. And we have to write an algebraic expression for that. Now, if you've watched any of my other videos when we're talking about story problems, I'm going to show you a little trick that my algebra teacher taught me a long time ago. And that is, start at the end of this thing and work your way backwards. Well, what are we calling the first angle? Well, we're calling it x. Keep working your way backwards. What would be 3 times the first angle? Well, that would be 3x. Well, how would you write 16 less than that? Well, it means minus 16. And there's your equation for the second sentence. Go ahead and solve this. Pause the video and solve it yourself. And here's the remainder of that problem. Next page. In a set of 2 numbers, the second number is 3 times the first number. We have the second number, we have the first number. Let's define our variable accordingly. We've got x is equal to the first number, y is equal to the second number, and then it says the second number is 3 times the first number. Take that sentence and translate it. Find the verb. Is. What is? The second number. What are you calling the second number? Y. So y equals 3 times the first number. That would be 3x. Also, 3 times the first number. What are we calling the first number? X. What's 3 times that? 3x. Increased by plus 4 times the second. 4y is 30. Pause the video, solve it yourself. And if you've solved this properly, you would have had the first number being 2 and the second number is 6. In number 9, it's very much set up like number 8. Go ahead and define your variables, write your equations, and see if you can come up with the answer. Go ahead and pause the video and come back when you are done. So 3x minus 4y equals negative 10 and 5x plus 8y is equal to negative 2. It looks like these are lined up to use elimination, and we are going to use elimination. And notice the y's here. Those will cancel out if the top y were a negative 8. If this number right here were negative 8 instead of negative 4, we would be able to cancel out the y's. Well, we can do that. All we have to do is multiply the top row by 2. 2 times 3x is 6x. 2 times negative 4y. There's your negative 8y. Now that's going to get the y's to cancel out. So we had to multiply the top row by 2 equals negative 20. Now I can add the 2 equations together to cancel out the y's, and I'll get 11x is equal to negative 22. X equals negative 2. So that means the first number is negative 2. So how do we find the second number? Well, we can plug negative 2 back into either one of these 2 equations for x. So x being negative 2, I'm going to have 3 times negative 2 minus 4y equals negative 10. Negative 6 minus 4y equals negative 10. Adding 6 to both sides, negative 4y is equal to negative 4, and y is equal to positive 1. So we have the second number being 1. In number 10, it says that we need to find the value of the collection. In other words, how much money do you have? We've got a bunch of nickels, we've got a bunch of quarters, and we need to find out how much money we have out of these 25 coins. Then it says there are 3 more nickels than quarters. So here's what I'm going to do. Before I can find out how much money I have, don't I have to know how many of each one. So that's what I really need to ask myself is, what am I finding here? I'm finding the number of nickels. So let n equal the number of nickels, and q be the number of quarters. Now I have 25 coins altogether, so n plus q is equal to 25. Now the second one, there's a couple of different ways we could write this equation. I'm going to show you what I would do here. Here's the way I look at this. I have more nickels. That means it's the bigger number, which means the quarters is the smaller number. What do you do with bigger numbers and smaller numbers? You subtract. So the bigger number being the n minus the smaller number being q would be equal to what? Yeah, it's equal to 3. Now, keeping in mind that you are always adding to solve a system of equations when you're using elimination. For those of you in my class, you're always going to add. So n plus n is 2n. The q's cancel, equals 28. N is equal to 14. So that must mean there are 14 nickels. Well, if there are 25 coins, that must mean there are 11 dimes. Are we done here? No. How much do we have? 14 nickels is 70 cents. 11 dimes is $1.10. We must have $1.80. And then number 11 is very similar to it. P is pennies, N is nickels. We have 11 more pennies. Pennies is the bigger one, bigger minus smaller. So P minus N is equal to 11, as well as having 47 coins. P plus N is equal to 11. There's the rest of that problem. So hopefully in number 12, we're seeing that since we have 60 quarters and dimes, if Q is the number of quarters and D is the number of dimes, you have Q plus D is equal to 60. Well, it's the other equation that might get us give us a little bit of a problem. The total value is $9.75. Now, doesn't that mean that each quarter 25 cents each, operative word being each here, each dime 10 cents each? What does each mean? When you're using algebra, each means to multiply. So we're going to be taking 25 times every quarter, 10 times every dime. So here's your other equation. 25Q plus 10D is equal to 975. Now I've taken out the decimal points here. Otherwise I would have to use 0.25, 0.10, 9.75, but I took out the decimal points and just made it 25Q plus 10D equals 975. And now it looks like these are lined up in order to use elimination. I could eliminate the Q's or I could eliminate the D's. It does not make any difference as to which one you're going to eliminate. How will be a little bit of a difference though. I'm usually just going to cancel out the Q's. If I have a 25Q here, I would need negative 25Q here. So I'm going to take this top row and multiply it by negative 25. Go ahead and do that. Pause the video and see if you don't come up with the same answer I do. Solving this system, multiply the top row by negative 25, allows the Q's to cancel out. You get negative 15D is equal to negative 525. 35 dimes, 60 coins altogether means there's 25 quarters. Go ahead and see if you can do number 13 on your own. And there's your answer for number 13. We have 3 quarters and 14 dimes. And number 14, Dave bought a total of 8 pounds of walnuts and almonds. Walnuts are $2 per pound, almonds $5 per pound. David spent $25 on these different kinds of nuts. How many pounds of each did he buy? When it tells you what you're finding, that's how you're going to define your variables. How many of each kind did he buy? So let W equal pounds of walnuts, and A is the pounds of almonds. Bought 8 pounds altogether. Don't think we're going to have a problem with that one, but think about this. Per is kind of like each. Per, each. It means to do what? It means to multiply. Each and per means to multiply. So we're going to be taking 2 times the walnuts, so 2W, plus 5 times the almonds, 5A, equals, and how much money did we spend? $25. Multiply through by -2 to cancel out the W's, and you'll have your answer. Go ahead and do that, and we'll come back and see if you're right. So you should have come up with 3 pounds of walnuts and 3 pounds of almonds and 5 pounds of walnuts. All right, number 15. Let me walk you through this one. 350 tickets to the basketball game were sold on Friday. Student tickets were $1.50 each, right? What does that mean? Non-student tickets were $3.25 each. The school earned $752.50. How many of each were sold? Well, let's do this. Let X equal the number of student tickets, and let Y equal the number of non-student tickets. How many tickets were sold? 350. So X plus Y is equal to 350. Now that shows you the number of. Now we want to talk about value. Now we're going to be talking about money. Each means times, right? So we're going to take $1.50 times all the student tickets, which is what we've defined as X. So 150X plus, right, let me put an X there, right? 150X. Let's just start that one over. 150X plus 325Y. Why did I take the decimal points out? Because I don't like dealing with decimals, so we're going to write this without the decimals. Also, so we have 75250. I'm just going to go ahead and make a blanket statement. Let's just cancel out the X's whenever we can. Multiply the top row by -150 because I need a -150 to cancel out +150. So I'm going to have -150X. I'm multiplying here, right? I'm going to have -150Y equals, and I'm going to take -150 times 3 and get -52,500. Now I'm going to add these two equations together, and my x's will cancel out. So I'm going to have 325 minus 150 is 175. So 175y is equal to -52,500. When you solve this system, we get 325 minus 150 is 175. Y is equal to 22,750. Dividing both sides by 175, you get y is equal to 130. So the non-student tickets There were 130, which means there were how many student tickets? Well, since there were 350 sold altogether, that must be 220. And there is how you solve story problems using systems of equations. Good luck, and we'll talk to you in class.